You already know how to make a list bigger. Now the other direction, taking elements out. Python gives you 3 ways to do it: by position, from the end, and by value. They look alike, they all mutate the list in place, and exactly one of them hands the removed value back to you. Start with the syntax. If you know the index of the item you want gone, the first one, the last one, the halfway point, you use del. Write del, then the list, then the index in square brackets, and Python deletes whatever sites at that position. Second, if you want the item all the way at the right-hand end, call L.pop with nothing inside the parentheses. Python grabs the last value and drops it from the list. Third, if you know the value rather than the position, call L.remove and pass in the element itself. The string Anna, the number 5, whatever it is. Position and value, 3 different keys into the same list. Last lecture's clear wipes out every element at once. These 3 take out specific ones. Pop is the odd one out, and the dot notation is Y. We met the dot last lecture with append and clear. Those calls work by side effect. They change the list and hand nothing back. Pop does both jobs. It mutates the list by dropping the last element, and it returns that element's value so you can catch it in a variable. Take L holding 10, 20, 30. Write last equals L.pop. Afterwards, L is 10, 20, and the variable last holds 30, the value that just left. Then remove the value 10, and note we are naming a value here, not a position. Del and remove have no return value at all. Assign a variable from a call to remove, and that variable is none. Del is not even a function call, it is a statement, so there is nothing to assign from in the first place. If you want to keep what you removed, pop is the only one of the 3 that will tell you. Remove searches by value, and it stops at the first hit. Say a list called names holds Anna, Ben, Anna, Chris. Call names.remove and pass the string Anna. Python scans from index 0, finds the Anna sitting at the front, deletes that one element, and stops looking. The list becomes Ben, Anna, Chris. The second Anna is untouched. That is the misconception worth killing now. Remove is not remove all. One call removes one element, the earliest match, no matter how many copies are in there. If you want every Anna gone, you call it again, once per copy. Hold on to that, because it is exactly the problem we solve at the end of this video. Now watch what happens when the calls stack up. Start with L holding 7 elements. 1, 2, 3, 6, 3, 7, 0. Every operation here mutates L in place, so each call works on the list the previous call left behind. First, L.remove of 2. Python scans from the front for the value 2. It sits at index 1 just after the leading one. That element comes out, the list shrinks to 6 elements, and L is now 1, 3, 6, 3, 7, 0. Second, L.remove of 3, operating on that mutated list. There are 2 3s in it. Remove takes the first one it finds at index 1. The other 3 survives, and L becomes 1, 6, 3, 7, 0. Third, delete by position. Working on 1, 6, 3, 7, 0, we write del L at index 1, count from index 0. Index 0 holds the 1, index 1 holds the 6. So the 6 is deleted, and L becomes 1, 3, 7, 0. Notice we asked for a position, not a value. Del never looks at what the element is. Finally, L.pop. No arguments, so Python takes the element at the far right, which is the 0. L is left holding 1, 3, 7, and because pop returns what it removed, we can write dropped equals L.pop, and the dropped holds 0. 4 calls, 4 different sets of contents, but only one list object. Each operation rewrote it for the next one. That is what mutation means, and it is why the order of these calls changes the answer. Remember remove all from the exercise. We copied the list, cleared it, then appended back every element that did not match E. Remove gives us a far shorter route. We know the value we want gone, and remove deletes an element by value, So the body is just L.remove E, but that kills only the first copy, and the list may hold several. So wrap it in a while loop, while E in L, call L.remove E. The expression E in L evaluates to true or false depending on whether the value is still present. Each pass deletes one copy and shortens the list, so the test eventually goes false and the loop stops. If E was never in the list, the body never runs and L is left untouched. Run it on the same list we used before, 1, 2, 3, 4, 3, with E as 3. 2 passes strip both 3s. The test goes false and L comes back as 1, 2, 4, exactly what the copy clear append version gave us. 2 lines, same answer, and no new list is built. L itself is mutated, which is exactly what remove all promised. 3 removals, 1 list. Del takes a position, pop takes the end and gives the value back. Remove takes a value and deletes only the earliest match. Every one of them mutates the list in place rather than building a new one, which is why stacking them up means each call starts from the list the one before it left behind. Keep that reflex. The list you're holding has already changed. To practice what you just learned, this course has free exercises and AI graded feedback on ludium.ai. The link is in the description.